Hello friend, how are you? I hope you all will be fine. I'm also fine, thank you. Welcome to your channel that is AZ Science Group. Today is lecture number 4 of Boron Family, that is group 13. So in last previous lecture I already explained you, in last previous lecture I already explained you the general characteristics, general properties of Boron family. So in today's lecture we will be study about the abnormal behavior of boron. What is the abnormal in this group? In boron family, one element, that is boron, that show non-metal behavior, that has some abnormal behavior that is different from the other elements of the same group. So the anomalous behavior of boron. Today our lecture will be the anomalous behavior of boron, or you can say that the abnormal behavior of boron. Anomalous behavior of boron. So let's start the topic. Anomalous, that is anomalous behavior of boron. Boron differ marked from the rest of the members of the group, so that is group 30 elements, and this abnormal behavior is illustrated in the following properties. I will be explained one by one, bit by bit, with sequence, with proper number. Okay, number one. Boron with sorry. Boron show non-metallic characters, while other elements of the same group, while other elements of the group 13 are metallic in nature. Why? Why boron show non-metallic character? The one reason of non-metallic character of boron, that is the atomic radii of boron is very small. Atomic radii of boron is very small. Is very small. So, hence greater nuclear charge, greater nuclear attraction on the outermost electron. So that's why high ionization energy. That's why high ionization energy. This gives the boron distinctly that non-metallic character, while the rest are metals. I hope this will be cleared. According to Fajan rule, a small radii of the cation. Small radii of cation means that cation that has plus charge, when they have small size, it will have high polarizing power, and we know that the high polarizing power elements have low polarizability, and the elements that have low polarizability, it should have high ionization energy. When they have high ionization energy, it means it is very difficult to ionize the system. It is very difficult to ionize the atom. So that's why non-metallic elements are those elements that have high ionization energy, that in which, in the case of non-metallic character, in the case of non-metallic elements, the electron will be removed from the elements with very difficult, with very high energy. So that's why boron show non-metallic character. The second point is boron has maximum covalency of 4, while the rest of the elements of the same group have maximum covalency of 6. Covalency means the number of bonds that can be bonded by borons. Boron can make 4 bonds, 4 covalent bonds. Let's suppose that is in case of BCl3. Boron has, we know that boron has our group 13 elements are electron deficient elements. So the Lewis space, according to Lewis concepts, it will be act as a Lewis acid, so that's why it can accept another pair of electron, that is the Cl that have lone pair, Cl negative, so it can be accept those pair. So boron can have maximum covalency of 4. Why boron has maximum covalency of 4 while other elements of the same groups have 6? Because boron have, in the electronic configuration of boron has 5 electrons. So electronic configuration is 1s2, 2s2, 2p1. This is the electronic configuration. It means in case of de-excitation, in case of excited state, that is the ground electronic configuration. In case of excited state, the configuration become 1:2, 2:1. This electron will be shifted toward that. That will be like that. That is the outermost electron, outermost shell. That is 2s2. Here is 2 electron, and here is 2. In case of 2p1, here is 1 electron. So this electron will be shifted here due to excitation after the gaining energy, and it will be like this. It will become, here is 1 electron, 1 electron, 1 electron. So here 3 chlorine are bonded with this boron, while one another orbitals will be vacant, which due to this vacant orbital, the boron is also called electron BCl3 is also called electron deficient compounds. So here is only 2p orbital, the maximum 2p orbital is present. While in case of aluminum, in aluminum the valence shell is n2 np1, that is 3s2 3p1. So here also 3d0 present. In case of 4s2 4p, that is in case of gallium 4p1, 4d also present, 4d0 also present, 4f0 also present. So that's why in case of boron there is no extra valence vacant orbital present, but it is only one orbital that can make completely 4 covalent bonds, that make 4 covalency of the boron, while the rest of the elements of the same groups can have maximum number of maximum number of covalent bond, that is 6, due to the extra d orbital is present. I hope point will be cleared. The next point is allotropy. Boron show allotropy while other elements of the group 13 doesn't show allotropy. First of all, we should need to know what is allotropy. Allotropy can be defined in when a chemical elements can exist in two forms. The elements can exist in two forms. Are more that can exist two forms are more than two forms. Two are more than two forms. Are state or phase. This is called allotropy. For example, boron can, in solid case, boron can exist in a crystalline form, also can exist in amorphous form. So it have two existence. That's why it show allotropy, and according to definition of allotropy, boron show allotropy, while other rest of the elements of the group 13 doesn't show allotropy. This is one anomalous behavior, one unique behavior, abnormal behavior of boron. The next anomalous behavior of boron is boron show +3 oxidation state, while other elements of the same group of the group 13 elements can show +1 and +3 oxidation state. Means that is let's suppose here, in case here, that is boron, aluminium, gallium, indium, and thallium. So here boron show oxidation state. Boron show +3 oxidation state, while aluminium can show +3 oxidation state and can show +1 oxidation state. It can show +3 oxidation state and +1 oxidation state. +3 +1 +3 +1. It can show +3 +1 both oxidation state, while boron will be only show +3 oxidation state. That is also the unique behavior of boron. In case of why all other elements except then boron can show +1 oxidation state, why? The reason of this question is that show due to inert pair effect. Due to inert pair effect, +1 oxidation state can be exist by the other elements of the group. So I hope this point will be cleared. And in previous lecture I explained inert pair effect with very details, if you have remembered. Also I dropped the description box. I also dropped the link of the video in description box, in which I explained you inert pair effect. Boron doesn't form cation in aqueous solution, while rest of the elements of the same group of the group 13 can form cations. So why boron doesn't form cation in aqueous solution? The cations for aqueous solution, the one condition is necessary for the formation of cation in aqueous solution, that the sum of the three successive ionization energy should be greater than the hydration energy should be greater than the sum of the three successive ionization energy. The hydration energy should be greater than sum of three successive ionization energy. This condition is necessary for the formation of cation in aqueous solution. But here I already explained you in the previous lecture what is hydration energy and how hydration energy can be exceed the three successive energy, sum of the three successive energy in case of aluminum. I explained you with very details. So all the other elements of the groups, that is aluminum, gallium, indium and thallium, that can have the hydration energy very high and exceed to the sum of the three successive ionization energy, while in case of boron doesn't have enough hydration energy. The hydration energy of boron in case of boron is less than the sum of the three successive ionization energy. So that's why boron doesn't form cations in aqueous solution. I hope this point will be cleared. Boron halides are monomeric while the halides of the other elements are dimeric. Why the boron halides are monomeric? First of all, you should need to know that what is monomeric and what is dimeric. Monomeric is a relatively small molecule which can be covalently bonded to the other monomer to form a polymer. It can be the polymer is the result of the sum of the two or more than two monomers, while dimer is the molecule dimeric form. Dimer is a molecule consisting of two identical halos formed by joining two identical single atoms acting as a bridge, like in case of aluminium. In case of aluminium, that can form dimerics, that is Al2Cl6, that can be formed in dimeric form. But boron halides are in monomeric forms, that will be all in monomer forms. So why boron halide? It doesn't show inert pair effect. Boron halide, because boron halide doesn't show inert pair effect, so that's why it will have the properties of monomeric because due to inert pair effect. So the another anomalous behavior that is different the boron from the rest of the elements of the group 13. Boron form a number of volatile hydrides which are electron deficient compounds. This is the unique property of boron, while other forms only one polymeric hydrides. Other elements of the groups are formed one polymeric hydrides, while other elements of the group form polymeric hydrides. Group only form polymeric hydrides. Polymeric hydrides, while here is one another case arises. Thallium doesn't form any hydride. Thallium doesn't form any hydride. Why thallium doesn't form any hydride? Here in this group of from boron to aluminium, the formation of hydride, the the formation of hydride decreases. Means it means that formation of hydride decreases. It means that boron will be formed hydrides are very good, while decreasing in down the group the formation of electron, it will be formation of hydrides, it will be decrease. Why it will decrease? First of all, it is due to the inert pair effect. The second reason is that in case of boron, hydride, let's suppose this is the boron structure. In case of boron, N is 2, Np. In case of boron, the valence shell is 2s2 and 2p1. Here, in case of the valence shell, which is 2p, in case of boron, which is 2p, that is 2p orbital of boron, in case of hydrogen, which has 1p orbital, which has 1s orbital, the energy difference between 1s and 2p is not enough, is not the energy difference is not greater, so that's why it can make easy covalent bond. While in case of aluminum, the bonding orbital is 3p. In case of aluminum, the bonding orbital is 3p. While in case of gallium, the bonding orbital is 4p. In case of indium, 5p. While in case of indium, 6p. So that's why the combining orbital is have very high difference in shape and in symmetry. That's why the combination will be not effectively, so that's why down the group the combination will be not effectively, and the formation of hydrides ratio will be decreased. Thus thallium cannot form any hydride due to the very large difference in the shape of the 1s orbital of hydrogen and the 6p orbital of the thallium. I hope my point will be cleared. The another anomalous behavior of boron is boron doesn't decompose water or steam, while rest of the elements, that is aluminum, gallium, indium, thallium, the 13 groups elements can be decomposed by hot water or steam. This is the one unique behavior of boron that differentiate boron from the other element, from the rest of the elements of the same groups. The another anomalous behavior, the another different behavior is that the oxide of boron is acidic in nature. Oxides of boron is acidic in nature. Oxides of boron is acidic in nature. What this mean? While the similar oxides of the other elements are either amphoteric or basic. So while similar oxides of the other elements are either amphoteric or basic. Amphoteric or basic. So this is the some behavior that differentiate boron from the other elements of the boron family. I hope this point will be cleared. Okay, if you have any confusion, if you have any question, you can drop in comment section your question. I will be reply you. I will be try my best that your point will be cleared. Okay, thank you. Let's proceed to the topic. The explanation of previous point that the oxide of boron is acidic in nature. Why oxides of boron is acidic in nature? When boron oxide reacts with water, it forms an acid. That's why it is an acidic oxide. But here in case of in next pointer, boron is not attacked by non-oxidizing acids. What is meant by non-oxidizing acid? Non-oxidizing acid are those acids that have not oxygen atom, that cannot be oxidized in other atom, that cannot be have ability to add the oxygen or to add the oxygen to the another elements. So non-oxidizing acids are those acids that contain oxygen atom. Oxidizing acids, those acids those acids that cannot have oxygen atom, like in case of HCl. HCl is not oxidizing acid. So HCl is not oxidizing acid. That's why HCl cannot be attacked on boron, while other elements are attacked. HCl can be attacked on the other elements of the group, that is aluminium, gallium, thallium, and indium. It can be attacked. So non-oxidizing acids. Boron is not attacked by non-oxidizing acids such as HCl, but reacts with oxidizing agents such as concentrated HNO3. Concentrated HNO3 or H2SO4, that is sulfuric acid, that have oxygen atom, that are oxidizing acids. But the other members of the group reacts with the non-oxidizing acid, a typical metal, and evolve hydrogen. While the other elements, that is aluminum, that can be react with HCl, and in the result, hydrogen molecule will be evolved. This is one of the unique behavior of boron that differentiate boron from the rest of the elements of the group 13th. I hope will be cleared. The other elements, the other points that differentiate boron from the rest of the elements of the groups. Boron dissolve in concentrated nitric acid, that is HNO3, and produce that is H3BO3, that is also called boric acid. So it can be produced, boron can be produced boric acid, while other elements become passive, especially aluminum and gallium, that cannot be react with concentrated HNO3, but it can be react with the dilute HNO3, not the well the concentrated. There is a lot of difference between concentrated and dilute. And concentrated, the concentration of acid will be lesser, while in dilute the concentration will be more, and in dilute concentration will be less, while in concentration will be more. Sorry. But the other elements can be attacked, can become passively attacked, that is aluminum and gallium, while the other element, that is thallium and indium, cannot be dissolved in concentrated HNO3. The next point is, that is 12 points. Boron can combine with metal, combines with metals, and form borides, while other elements do not combine. Boron combines with metal, with metal while the and form borides, while the other elements the other elements of the same group, of the group 13 of the Boron family, do not combine, but the other elements can be combined with the metal, and they will be formed ally. They will be formed ally. They will form ally. They cannot form borides. They cannot form, that is halide, that is for aluminum, for gallium, but it will be only form allies. I hope this will be clear. These are all about the boron family, that is anomalous behavior of boron. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. Now please, you can take screenshot or you can rewind the video for better understanding for recording. Okay, thank you. you can take screenshot. That is the lecture number 4 end. Okay, thank you very much. Very best of luck, my dear student. Also subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you. Very best of luck.